Now we will continue our discussion with vectors. So we have seen how to represent graphically a vector. Now what does this mean? Let's see. I am saying that OA is 70 miles per hour, 30 degrees north of east. That means if a person starting here is moving in the car with 70 miles per hour, he is going in this direction. So after 1 hour, he will reach this point, let's say, that is 70 miles distance. That's good. But how much did he travel and in what direction did he travel is 70 miles in 1 hour in the direction of OA bar. That's good. But how much did he travel in the east direction? How much did he travel in the north direction? This is of great importance. So, this vector OA has two perpendicular components. One is along east direction, this is this length, and one is along this direction, this length. So these are called components of a vector. So any vector can have two rectangular components. So this vector OA bar, which has a component OE along east and ON along north. So what are the values of these components and what is the use of these components? That's very important for us now. So we are going to talk about this resolution of the vector into two mutually perpendicular components. So how to resolve this vector is from trigonometry we know that this is a right angle triangle. So I have dropped a perpendicular here. So this is 90 degrees. Then this component OE can be represented as the length of OA. So OE equals OA cosine of 30 degrees. Similarly, ON is equal to how much? ON equals OA sine of 30 degrees. How do I know that? Because ON is parallel to EA and also equal in length. Therefore, if I measure AE, which will be AE equals OA sine 30. So this length is exactly equal to ON. So ON can be represented as OA sine 30. So this angle is important to us. Now some of you may think, why can't I take this angle? Yes, you can take. If I take that, this is 60 degrees. Then under these circumstances, ON will be equal to, I'll write it here, ON equals OA cosine of 60 degrees. Didn't the value change now from ON is equal to OA sine 30 to ON is equal to OA cosine 60? Now, this OA and OA are same. Cosine 60 is exactly equal to sine 30. Therefore, I can take this angle or this angle. The only thing is you should know when to put cosine and when to put sine. I kept for OE, that is this length, as OA cosine 30, cosine, because if the adjacent side, this angle is adjacent side of OE. So this is called adjacent side. So for adjacent sides we put cosine. And ON is opposite to 30 degrees. That is opposite 30 is AE and AE is same as ON. So therefore for opposite sides we put sine 30. So when I am putting this as 60 degrees with north, then ON becomes adjacent to 60. So OA cosine 60. Now, how do I represent OE, which is opposite to 60, because OE is parallel to NA. So, NA equals OE, which is equal to, since 60 opposite to that is NA, I'll put OA, this length OA, times sine of 60 degrees. You can see that OE is OA cosine 30 or OA sine 60, because cosine 30 and sine 60 are same. The result will be same. So these two, OE and OM, are called the components of the vector OA. Why do I require components? Because I know when a person travels from here to here, he just not traveled from O to A, but he also traveled towards east some distance, towards north some distance. So both put together he traveled this way. That's the use of the components. Components will give you the results along two mutually perpendicular directions. So we will continue this talk in the next class.